Hello, everyone. I would like to thank you for attending the Essentials of Data Science and Statistics webinar organized by Editage. And my name is Darko Medin. I'm a data scientist and a statistician working with different research institutions and companies in these areas. And I will be today's speaker about some very important concepts of data science and statistics. One of the most important aspects of data science is learning about different areas where data science can be used, and for statistics, how statistics can be used to improve research, and we will be discussing all these details uh, later through the webinar. For now, I would like to introduce you to some aspects about the company that's organizing this webinar. So, Editage, one of the world's foremost academic solutions partner for different research institutions, researchers, journals, publishers, and corporations worldwide, with the vision and mission to accelerate global scientific research communication by facilitating certain aspects of both research and industry elements, especially in research publishing areas. So, as you can see, there are different other names you can see here on this slide, like Impact Science, Cactus Life Sciences, and Silo, Cactus Labs, and Researcher Life. So, Researcher Life is another platform which is very interesting, and I will also introduce you to certain elements that can be accessed through the platform. So, Researcher.life is a platform that can be used to manage your research publication from start to finish and optimize certain elements like optimize writing manuscripts, optimizing journal submission aspects, editing, stay up to date with different personalized recommendations, and find different courses which are very, very important in different research areas. There is a starter pack which can be accessed for free and provide a lot of important resources for publications and research and learning different areas connected to some of them are connected to data science, some of them are connected to research in general. You can check all these out by going to researcher.live website, and there are also other paid and premium options to go through and see if any of them are applicable for different researchers, authors, or anyone in general interested in using this platform for different research purposes, or just facilitating other aspects of publications and similar areas. Another important aspect is the community, and as you can see, the last box is connect with the community. This is very important in research and is also important in data science and statistics. A lot of very important aspects, tutorials, problem solutions are achieved through connecting with the community. So that's another very, very interesting aspect of researcher.life. Now, why is data science and statistics important? Why it's also a good career option? So it's important to understand that this is the skill that's highly in demand today. It's deployed by most companies in the world, and not just companies, but also research institutions which are from the academic background. Learning data science and statistics often includes learning state-of-the-art areas of science like machine learning, artificial intelligence, image recognition, and many more. I will be discussing these through the webinar. Statistics is also used in most research areas. So whenever research findings are published, most of the time, some type of data analysis is associated with the research itself. So a lot of research today is data-driven, and statistics is often used to derive insights from that data and later provide results to answer the research questions. So as you can see, data science and statistics are very similar terms, and it's very important to clarify when is data science term more appropriate and when is statistics term more appropriate. And both of these are very good career options, which will be clearly shown throughout the next parts of the webinar. And this webinar is meant for anyone interested to learn more about data science and statistics, but also for academic researchers to improve their research through deploying different data science and statistics methods. For academic researchers, it's very important to understand the concepts of data science because most of the academic research today is dependent on the data. And this data, let's say, tells a story. There is actually a very popular term today, which is called data storytelling. So a lot of data storytelling is actually included in today's research and science. So being data literate and understanding statistics is a very important part of research for any researcher, not just for data scientists and statisticians, but also for researchers in any other area. So the key learning outcomes are you will understand data science use areas and its potential as a career path. You will also understand statistics concepts and how statistics can be used to solve certain research problems. Very important, understand what tools can we use to resolve these data science and statistics problems. And last but not least, you will understand some specific examples. This is probably most important, the practical part, right? So understand what are these specific examples of using data science data science in both research and industry areas. So if you take a look at this slide, it shows large number of different areas where data science is used. So on the left side, you may observe engineering, telecommunications, security, banking. So it's one very specific area of engineering, banking industries, and telecommunications, etc. On the other hand, data science is also used in sciences and research like meteorology research, bioinformatics, environmental protection research, life science industry. So it's totally different area compared to, let's say, banking and telecommunications, right? But data science is used in all these different areas. You may also find recommender systems, natural language processing, artificial intelligence, so some very interesting and state-of-the-art domains where data science is used. In addition to that, metaverse, which is one very interesting area today, uh, mentioned by different companies like Meta, one of the world's largest companies. And data science is also used in other areas like economy, for example, retail or market research. So, if you just take all these aspects into consideration, one conclusion is very clear. Data science is used in most industries today, from research to banking and social media and economy, right? So there's a very diverse set of uses for data science. And that's, of course, one of the reasons why data science is one of the most promising and growing career paths today. So it's not just about the fact that it's well paid, it's one of the most paid jobs out there. It's also about the fact that it's used in many, many different areas, and the use cases are, let's say, state of the art use cases very often, whether it's the research or just one of these uh, segments that I've been mentioning before. On the other hand, statistic, or let's say, when we say statistic or statistics, we generally think about mathematics, different formulas, or data analysis, analytics, how to derive results using certain data. And this is exactly what differentiates general statistics term from data science. Statistics is used for a very specific set of problems, and most of the time these problems are associated either with research or other types of analytics like business analytics. As you can see from the images presented, statistics would be a combination of mathematics, deriving insights from data, interpreting results, and one very important concept which is often overlooked is making decisions. So statistics, as well as data science, is often used to facilitate the decision-making process. So these are two very, very characteristic areas of using data science and statistics, and I will be discussing these more later. Of course, one of the key aspects to understand whether it's data science or typical statistics is what tools can be used to resolve certain problems. When I say tools, it's not just about, let's say, computer programs. It's also about the programming languages today. Right? So, a lot of discussion about tools is also discussion about programming languages that those tools implement. So, I know programming language, especially for people who are not familiar with programming languages or programming in general, can be something which is daunting, which looks like very complex codes and scripts and similar. But programming languages, especially in data science and statistics, are not that difficult to grasp. In fact, they're very logical. That's why they're called programming languages. So they're very logical, and with certain amounts of learning, they get easier and easier. So it is also one aspect to consider that different types of tools are used in data science, but also different types of programming languages. Now, when I say tools, I mentioned before that programming languages are used, but there are also different types of software, which are called integrated development environments sometimes. Sometimes they're called just programs, just software, depending on the terms used. But generally, this software or IDEs are used to facilitate the process of performing data science or statistics for non-programmers, right? So whether we're talking, for example, about the SPSS, MATLAB, JASP, Excel, Tableau, Power BI, there are many other software which I didn't mention here. Most of them are used somehow to facilitate the process for non-programmers. Some of them have this, let's say, hybrid way of functioning where there is a little bit of programming, but there is a lot of facilitation. There are a lot of, let's say, point and click operations in the software. So those terms you can see on the left side actually are the names of different software, and they can be used to facilitate the process, let's say, of statistics for researchers who are at the beginning of the journey in data science and statistics. So as you can see right there, there is Excel. Believe it or not, Excel is one of the most used software in data science and statistics. So it's actually one of the most important softwares out there, and it's very easy to use, right? So it's always recommended to start with such software and then go towards other programming languages which are used for advanced data science. As you can see on the right side, there are most popular programming languages. There are many of them out there. Some of the most popular are called R, SQL, and Python. And I will be discussing R and Python in detail today, but there are many other programming languages like SQL, SAS, Java, Julia. There are many programming languages out there, but in general, these are the most popular among them. For example, R programming language, one of the best programming languages for statistics, for data science, and for machine learning. So as you can see, there is a very, very diverse set of uses where such programming language can be implemented. Some of the most important aspects of this programming language are very large communities, large amount of tutorials out there, so virtually anything from R or implementing R in different situations can be learned today using different tutorials, courses, webinars. So there is a very, very large amount of resources out there for these use cases. The third point is documentation. Why is this important? Whenever software is used either in data science or statistics, it's important to have documented, or let's say well-documented, methods that are deployed or used in certain research. R is really one of the best programming languages when this aspect is considered. Virtually, there are tens of thousands of different packages for R. They're mostly well documented, and this is very important when publishing research or we're communicating with different research institutions. Another important aspect is that R is open source, and this is partially the reason why there are so much resources out there. So it's open source, it's available for anyone to use for free, and this is really great for both researchers and data scientists out there because this facilitates their use in all parts of the world, and their use is very, very accessible to everyone. On the other hand, R can be used to create advanced apps. It can be used for validation of different types of research. R itself is well validated because there are a lot of resources out there. There are a lot of people resolving problems in R programming, so it's very, very well validated. One of the things that I would mention when R is in question is that it also has one IDE, Integrated Development Environment, which is used to facilitate programming in R. It's called Rstudio. So Rstudio is essentially a program that facilitates the use of this programming language, and of course is advised to use for all kinds of different use cases. So another programming language called Python, it's also very popular. It's in most ads about job postings out there, and is very, very frequently present in many companies for different uses. One of the best programming languages for AI, data science, and machine learning. So AI, data science, and machine learning they're all characterized by very often using large amounts of data. And this is really where Python is one of the best languages out there because it's optimized for speed and efficiency with using large amounts of data and creating different algorithms to make these algorithms work better, faster, more efficiently. This is really why Python is preferred among data scientists interested in, as I said before, AI and machine learning. So it's multi-purpose, it's well integrated with other languages. It's also open source, which is also great for all data scientists and statisticians out there. It's also well validated, and as I said before, it's well optimized for large amounts of data. Now, I mentioned programming before as one aspect. So programming or using different programs and tools is not the only important aspect. There's a lot of computer science and data science. So understanding how computers work, understanding how both software and hardware works is very important to consider in computer science, and as such, very important in data science too. In fact, the development of data science today is mostly enabled by development of modern computers and modern software that we can use in different ways. So development of different hardware like very advanced processors, graphic cards, other types of hardware, but also these programming languages and the ways they're implemented, they are the main facilitators of using data science in such a good way. So another important aspect to consider, learning about computer science too. Before I start with these specific examples, I would like to summarize some of the things mentioned before, which is that there are a lot of different use cases or different uses of data science and statistics, from research to using statistics and data science in banking, telecommunications, artificial intelligence, a lot of different areas. It's very important to consider what tools and what programming languages are used in data science and statistics, but also the computer science part. Now, when I mention all these, it might seem like it's very complicated, but essentially it's not. It's important to understand that all these concepts are very logical and are easily learned once the basic concepts of understanding data science and statistics are learned. So anyone can use data science, anyone can learn data science, anyone can learn statistics too, right? So it's not something which is reserved only for data scientists or even only for researchers. So anyone interested in these areas can learn either data science or statistics depending what types of the problems are to be resolved and in what area of research or other industries is the data science and statistics applicable in that case. Now I will move to some specific examples of using data science and statistics. As it can be seen on this graph, it says recommender systems and machine learning. On the right part of the slide, there are circles with YouTube, Facebook, and Twitter. All these have something in common. They're video companies or social media companies, but they have something in common, which is that recommender systems and machine learning are essential in the functionality of these platforms. For example, YouTube is mostly meant for videos and music as a platform, and it uses recommender systems for different aspects. Any video platform out there uses some recommender systems. YouTube is of course one of the largest platforms, and recommender systems are used to improve user experience so that videos and music can be recommended to users in a way that is most appropriate. On the other hand, one interesting fact is that YouTube itself, as a platform, is written in Python, one of the languages I mentioned before, right? So that fact alone tells us that it's very well optimized for data science, and data science is definitely one of the most important aspects of video platforms out there. On the other hand, social media is also very, very dependent on machine learning and data science. A lot of data is used in social media in different ways. There are also the recommender systems. Whatever we see in the social media, like likes, comments, the way posts are disseminated amongst the readers, all these aspects and all these processes are achieved through data science. So there are other social media out there like Twitter and Instagram, TikTok, many social medias out there. Here I just show some specific examples, and most of these social media, they use data science to improve the user experience on those platforms. So as you can see, it's one very, very important area where data science is used. On the other hand, if we observe this graph, which at the center has academic research, it's totally different area. So this shows how data science can be used for totally uh, different problem solutions for different industries, and that tells us how data science is one of the most important uh, career paths today, right? Because it's used in so many areas, and as such, is a very, very, let's say, not just advanced, but also in demand career path. So, in academic research, generally at the beginning, framing the problem is important, and then gathering the data that will be used to resolve that problem. Later, later come the next steps like data analysis, interpreting the results derived from the analysis, and making conclusions. But if a researcher does not understand how to frame the problem and gather the data in a statistically correct way, the problems can occur, and these problems, of course, later have to be resolved. So that's why it's important, not just for statisticians, let's say, to understand statistics. It's important for any researcher to understand statistics to a certain level, so that these processes in academic research can be performed efficiently and without errors. So most people think that statisticians should only know statistics and that they are the ones that are performing these analyses, but it's very important for academic researchers also to understand these concepts. And statistics is one of the most important segments of today's academic research. So virtually, or I would rephrase it like this, majority of academic research papers and publications use statistics to report the results. So if statistics is not understood well, the results cannot be interpreted well, the conclusions cannot be derived well, and as such, these processes are best performed and problems best resolved when we understand statistics to a certain level. There is a totally different area now called bioinformatics, which also belongs to academic research in a way, but it's also very present in different industries like pharmaceutical industry for the reasons of finding biomarkers, or in this case, we can see drug discovery, which is very popular today uh, for different types of problems in biomedicine, personalized medicine. All these require working with certain types of data. I mentioned here in this slide some of those, like gene expressions or mutations. So using large amounts of gene expression data, mutation data, other types of genomic data, bioinformatics can be used for drug discovery and personalized medicine, of course, in collaboration with other branches of science like medicine or biology. And one key concept here is that generally the most advanced parts of bioinformatics require working with large amounts of data. So again, we need data science to enable working with large amounts of data. We need certain algorithms that are going to enable us to use large amounts of data and process it efficiently to get the results. Right. So it's another very interesting use case of data science in bioinformatics. One of the uh, very important segments where data science is also used is banking, anomaly detection, finding flaws in the, or finding problems, let's say, of security nature, also for data analysis, when providing credits to client to assess the risk for that credit. So data science statistics is again used in banking. I must say that data science and statistics, since I mentioned a lot of these different use areas and frequently I mentioned data science and statistics, I explained later why statistics is more oriented towards research and data science is a much more general term, which includes statistics very often. We must understand that statistics and data science are complementary to each other. So let's say statistics is often used in data science, but data science is often important for statistics. So they kind of overlap frequently, and sometimes one form of analytics is, let's say, dominant. So in banking, data science is definitely dominant. and using different algorithms for, let's say, anomaly detection or risk assessment is much more frequently used than standard statistics. On the other hand, in academic research, statistics is often used for publications, for analyzing the data, but data science is also used. So most of the time, both of these terms are used to describe different ways to resolve problems in different industries. Last but not least, as I said before, metaverse is one of the most popular terms out there today, especially with a company like Meta, which owns Facebook, is interested in creating the metaverse, but also many other companies are interested too. And a lot of data science algorithms are to be used potentially in creating the metaverse. First, how to facilitate the communication between people, because social media is mostly about communication between people. So how to facilitate the communication between people from different parts of the world. One way is, of course, to have a very good translating algorithm that will automatically translate anything people say, even if they're speaking different languages. And this area is called NLP, or natural language processing. There are many other parts of the potential metaverse, like how to manage large amounts of data, how to create the 3D worlds or 2D worlds in the metaverse, and AI, or artificial intelligence, is often used in creating large, almost almost limitless worlds um, for these platforms. So again, working with large amount of data, working with large amount of different algorithms requires very specific data science skills, and that is another reason why data science is so in demand, especially today. Since I mentioned AI a couple of times before, AI, or artificial intelligence, is a very important, not just in today's research, but also in user experience for most of these platforms that I mentioned before. So it is definitely an advanced set of methods, and as such, very interesting as a career path. And as mentioned before, it's highly in demand. There's some very exceptional career options. One of the most important aspects of AI is it's very innovative. It uses state-of-the-art advanced algorithms to resolve certain problems, from biomedicine to metaverse to banking. So the AI is virtually one of the most advanced set of methods used out there today, and as such, a very interesting career path. Right now, I know I mentioned a lot of different details. There were a lot of different aspects and the diverse set of problems mentioned today. On the other hand, I discussed a lot of different aspects of both data science and statistics, and specific examples where these two are frequently used. So I totally understand that there will be certain questions, and you may feel free to post any questions in the chat, and I would be more than happy to answer any questions related to data science, to these specific use areas, to programming languages, to tools used in data science. So whatever is not clear 100%, feel free to ask in the chat, and I would be more than happy to answer any questions. Okay, so I'm already seeing some questions. First question from Osas. Please, can you make the presentation available to the participants? And we have a question from Aparna. How data science differs from big data and data analytics? So I will answer these two for now. First from Osas. I believe Editage will answer this question. So Editage will probably answer you in terms of having the whole presentation that I sent today. Question from Aparna. How data science differs from big data and data analytics? So big data is another concept which is frequently used today and is of course associated with data science. So big data means working with large amounts of data, and of course data science would be a set of methods to work with big data very frequently. So data science is very, very related to big data today. How can we differentiate them? Well, big data is referred to large amounts of data stored in different repositories, on different servers, generally big data or large amounts of data. But the data science itself is a set of methods that can be used with big data. On the other hand, I will just go through other questions. What about your opinion about R language from Neha? Thank you very much, Neha, for the question. So R language is personally one of my favorite data science languages. So why would I have such an opinion about R, having a lot of experience in R programming? Well, first of all, R is open source. I mentioned this before, so it's accessible to anyone. On the other hand, with R, possibilities are so large that virtually any analysis, almost any analysis uh, you can think of, can be performed in R. So there are packages for all kinds of data science and statistics problems, from biomedicine to bioinformatics to working in economy, banking, deep learning, artificial intelligence. So virtually almost anything that anyone today can think of in terms of different problems, R can be used to resolve most of those problems. Another question from Neha. Thank you very much, Neha. How can we clarify the result in a better way? One of the most important aspects, not just about data science and statistics, but in research in general, is interpreting the results. To be able to interpret results, we must understand how did we get to these results. So that's why I mentioned before, data science and statistics is not only for data scientists and statisticians. It's generally for everyone involved in research. So we must understand these methods to a certain level to say, okay, this methods or this method can tell me a certain answer to a certain research question. If we don't understand that, then the interpretation part is not easy. One of the best ways we can clarify the results even better is to use very good data visualizations. So the better the data visualizations are, the easier the results will be to interpret and understand for potential readers. And data visualization is another very, very important aspect in data science. So thank you very much for that question, Neha. Another question from Jacob. Which one do you think is the best for scientific computation, R or Python? Very good question. And this is the question that's very, very frequently asked in today's data science world. Probably two most popular languages for data science are R and Python. And people often compare them, right? So it's a logical question. I would say that both of these are the best, but in their specific areas. R is better if we have, or let's say R is better than most other programming languages if we have a problem which involves a lot of analytics, statistics, data analysis for a very diverse set of problems. On the other hand, if the problem is related more to having large amounts of data, creating algorithms that can predict certain future processes or certain future observations, creating models for artificial intelligence, models that can be used to facilitate certain areas of research and other industries, then Python is probably one of the best programming languages out there. So it really depends on where they're used. Personally, I I use both Python and R frequently, and exactly as I explained, if I need a more analytic approach, if I need a more, let's say, statistically oriented approach, I would I would consider R. If I need a more AI driven, if I need to create approach which involves creating models and working with large amounts of data, then I like to use Python. So I hope that answers the question. And thank you very much, Jacob, for the question. So we have a question from uh, a student, Nafur, and the question is, what is the relation of data science and AI? Very good question. A lot of these branches of today's modern research and computation use different terms, and data science is a very, very diverse term, let's say, diverse in a way that it explains a very set of diverse methods. A lot of algorithms used in AI are actually data science algorithms. So data science is the main driver of AI. We can say like that. On the other hand, AI has its own terminology and is its own definition. So AI would be using artificial intelligence in different ways. So using computer science, using hardware, robotics, different artificial ways of creating intelligence and creating different tools. I mentioned some of the most important. And the data science is the main driver in terms of providing the software part of the AI. So the AI often includes hardware, like let's say in robotics, the different parts of let's say robots or other hardware systems, and the data science is the main driver of the software part very often. So I hope that that answers the question. So another question from Abhishek: is there any free platforms offering certified courses on data science? So we mentioned before that one of the platforms that offers many courses in research, I believe a lot of them are actually related to using different aspects of data science and statistics in research. Some of them can be found in different platforms on the internet, and really today there are a lot of courses out there. So virtually there are thousands and thousands of platforms that can be found out there. And I would mention that Editage also has a set of 20 free courses, and some of them discuss some analytics processes in different ways. So I believe generally a lot of the resources out there are free, and I think just by Googling them or using other search engines, a lot of these free resources can be found. A lot of them offer different certificates, so there are definitely a lot of them out there. So let me just check the next question. How does one get an initial first job opportunity once they train in data science courses, ML and AI, and are there opportunities for remote worldwide roles outside the US and Europe? Well, I can tell you a perspective just from my experience here, from working around 6 to 7 years in different branches, industries, some of them involving statistics, some of them data science. For ML and AI, the first job opportunity is well, it's not an answer that is a typical answer, and there is no standard approach to getting the first job. Of course, one important aspect is having enough training, right? So once they train means that there must be enough training to be able um, to be able to perform different tasks in data science. On the other hand, knowing how to connect with different institutions, different people in data science, not just to learn from them, but also to network. And that's why I mentioned before, networking is very important, not just in data science, but in most other research areas. So that's why I mentioned that connecting and networking with people is really great. Having communities in data science and statistics is also really great. So, how do you get the job? It can't really be defined in a single answer, but there are definitely some aspects that I mentioned before, like having enough training, networking well, and definitely there are remote worldwide roles pretty much everywhere in the world, in all continents in the world, as far as I know. So I think data science is really one of the areas which is worldwide, right? So I believe there are a lot of world roles out there, and a lot of them are remote, especially today, right? When we live in a digital world where we can share knowledge online, where training can be done online, where jobs can be done online. So definitely today there are a lot of such roles out there. How large is large enough for big data science? Question from Neha. This is a very good question, also. So, all these questions so far have been great, and I think they're very informative for all the people in the webinar to understand these concepts. This concept of big data means that there is so much data. I wouldn't be defining this in numbers. There are different definitions out there, like which amount of gigabytes, megabytes, or which amount of rows, columns, observations. I would define big data as such a large amount of data that would require special or specific algorithms to process it, that cannot be processed otherwise than using data science algorithms to process it. Now, this scale might vary from, uh, as I said before, in different parameters from gigabytes, terabytes, petabytes, but generally these are very large amounts of data, and it would be unthinkable to analyze these very large amounts of data using standard approaches. So that's why data science is so important in a lot of problems today, how to resolve them and answer them. Uh, Another question from Neha: which is the best one, R or SQL? So I would give a similar answer as before with R and Python. They are both very, very good in their own specific areas. So R would be, let's say, very good for analytics, for bioinformatics, for statistics, for many other areas which involve data analysis and machine learning. On the other hand, SQL is very well optimized. In fact, it's one of the best programming languages for database creation. So, for example, knowing R and SQL is a very good combination. So, knowing how to create databases and then how to use data from those databases and analyze it using R is a very good combination. In fact, there are a lot of packages in R that enable users to use SQL through R. So one of those packages is called RSQL, right? So we can use SQL in R, and such combinations are very good. And one of the best advices I can give you in data science is not being focused on just one programming language. Saying, okay, this programming language is the best, and I want to use just that programming language. It's very important to know more programming languages. Of course, not every detail can be of course known for 10 programming languages, but to a certain level, it's always good to have a combination of these programming languages and know combinations of different methods, how to deploy them, how to solve different problems. Like creating a database is one way to address the problem, and then analyzing that database is another approach, right? So knowing SQL and R is ideal in that situation. Uh, okay, thank you very much, Neha, and fantastic questions. So another question: how do you define data science in short? Well, the definition is the definition is very, very, let's say, it's there is no standard way to describe data science in one sentence, right? Data science is a very diverse set of methods, going from business areas, from business analytics to statistics, uh, data management. Right? So very often this data needs to be managed somehow. And I mentioned database creation just moments ago. So creating databases, data management, uh, how to gather the data before it's actually managed, right? So is another aspect not to forget. And then after the data management, how to use this data, how to create algorithms later that can use this data, how to interpret results, how to create data visualization dashboards, how to improve business decision processes. So it's a very, very diverse set of areas where it's used. And I would say that data is really defined in A, working with different types of data. So any type of data we can imagine out there is related to data science, working with different types of data and having different algorithms and tools to manage and process that data. Right? So this would be like a very short definition, but there are many other aspects. Some of them I discussed during this Q&A session. Okay, so we have a question from Milanjit. How data scientists get promoted? To which positions? I heard it's a stagnant position, which is in demand, but with not much promotions. Okay, so this question, uh, I will try to answer it. So there are positions for junior data scientists, which are the beginning of their journey, and then data scientists get promoted to some medium, senior level positions, later at CTO, let's say, positions like Chief Technology Officer or directors of different parts of companies. So there is like a very, very large hierarchy of promotions for data scientists. One very important thing is that data scientists are very important in most industries today. So they are considered as essential in most companies, and that kind of facilitates this process that we're talking about. But I think I kind of answered the question. Uh, A question from Neha again. Is that a must to be proficient in R to use data science, or is there any other software to use data science? Very good question. Uh, it is, of course, optimal to know these programming languages like R, but there are many platforms out there that use no-code solutions. So data science can be performed without knowing the programming languages. There are many platforms that facilitate that, and they're called no-code data science platforms. So that is very interesting area also today. Another question from Tefera. Is there okay? So I think I answered Tefera's question, and sorry for mixing that up. So thanks for the question, and I think I answered it. Which job is better, a programmer or a data scientist? So they're often overlapping, right? So data scientists are most often also the programmers. But why it's good to be a data scientist is because data science is not just about programming. It's about resolving different problems. And as you saw from the webinar, resolving these problems in many different areas. That's why I think it's very good to be a data scientist too. So I see there are a lot of questions out there. I'll try to answer them quickly since the session is ending right now. So what's the best combination of data science languages to be good at? There isn't really one combination. So it depends on where it's used. For example, in my case, I use R and Python because I do a lot of data analysis and machine learning, right? So I have this combination which is applicable for those problems. But there are many people which use other combinations. I mentioned one of the combinations being R and SQL. There are other languages like SAS. Knowing software like Excel, other types of programs in detail is also important. So there are a lot of different combinations. And another question from Tefera, what is the difference between data science and citizen science? So data science is, as mentioned before, a very wide spectrum of different approaches, methods, tools, using these tools to resolve problems in data related situations. And citizen science is about pretty much everyone who is interested contributing to science. So any individual, any citizen, which can contribute to science or wants to contribute, uh, is very important today, and this is something which is being referred to as citizen science. So I believe that right now would be a good moment for me to just summarize all. So we talked about different aspects today. I hope this webinar has helped you in understanding essentials of data science, understanding how different concepts of data science can be used in different situations. And I would also like to thank you for attending the webinar, and hopefully it was very helpful to all of you who were present here today. And once again, thank you very much, and see you at the next webinars if any of you are interested, or other activities, communities related to data science. So that's it from me, and uh, once again, thank you everyone.